Good day viewers, you're welcome back to my channel. Today we have the following limit problem. Limit as n is approaching infinity, square root of n squared plus 3n minus n is equal to dash. If you want to make direct substitution here, we can see that infinity squared is infinity plus 3 times infinity, so we are adding and subtracting infinity, and which is not allowed in mathematics. Okay, so we're going to rationalize by conjugation. So what do I mean? We all know that the conjugate form of this sodic expression here, square root of n squared plus 3n minus n, is what? Square root of n squared plus 3n then plus n. Okay, so we're going to rationalize by conjugation by multiplying both numerator and denominator by square root of n squared plus 3n then plus n. That is the conjugate form of this sodic expression, then all over square root of n squared plus 3n then plus n. Okay, now remember this is over 1 here, so we're going to expand. So now we all know that we know the difference of two squares formula. Okay, that a minus b and a plus b is the same as a squared minus b squared. Okay, we're going to observe this property at the numerator here. Okay, here we have a negative sign, we have a positive sign, so this is the same as the square root of n squared plus 3n squared then minus n squared. Okay, so our limits will look like this. Limit as n is approaching infinity. Okay, now numerator here, so we have square root of n squared plus 3n squared minus n squared all over our new denominator here, so we have n squared plus 3n then plus n. Okay, now this is the same as limit as n is approaching infinity, n squared plus 3n and minus n squared all over square root of n squared plus 3n plus n. Okay, now we are proceeding, by the way, so we're going to simplify this numerator here. Okay, and by so doing n squared and n squared gets rid of, so we have limit as n is approaching infinity. Okay, 3n all over square root of n squared plus 3n then plus n. Okay, now what are we going to do? So let's think of dividing both numerator and denominator by n. Okay, so by so doing, our limit will look like this. Limit as n is approaching infinity, 3n all over n all over square root of n squared plus 3n then plus n all over n. Okay, we're going to split this denominator here and then simplify the radical sign. Okay, now we have here as follows. Limit as n is approaching infinity, up there we have 3 all over, if you want to split this, like I said, this denominator here, we have square root of n squared plus 3n over n then plus n over n. Okay, and because we have this root sign here, so if you want to simplify the expression with this root sign, so we can take n inside this root sign, but the n must be squared. Okay, so this is what I mean. Actually, this will look like this: n squared plus 3n all over n squared. So when we take root of numerator, we get this, and root of denominator, we get back our n here. Okay, so we have here square root of n squared plus 3n all over n squared. Okay, then plus n all over n, and simplifying this, so we have limit as n is approaching infinity, 3 all over in the roots, so we have 1 plus 3 all over n then plus 1. Okay, Now from here we're going to observe something here. We all know that 3 all over n, as n is approaching infinity, is approaching 0. So we have our limit to be 3 all over square root of 1, okay, then loss 0, then loss 1, okay. And from here, simplifying this, we have 3 all over 1 plus 0 here is 1. So we have square root of 1 is 1, then loss 1, and this is equal to what? 3 all over 2. And this is the right answer to the problem. Thank you for viewing, and please make sure you subscribe to my YouTube channel for more interesting videos.